Hello. We're going to talk about equivalent vectors. Today, equivalent vectors will be vectors that not only have the same magnitude or size, but they have the same direction. Okay? So right now, I have 2 points here. I have an initial point, 2, 3, which I'm going to label on the Cartesian plane 1, 2, 3. That's our initial point of our vector. Our terminal point of our vector is 4, 6. So we'll go to 4 and we'll go up 6. Now I know some of y'all are going, well, you're just plotting points. True, I am just plotting points. However, I'm going to connect these two and show that I have a vector. Now this vector has this particular magnitude and this particular direction. What I'm now going to do is I'm going to find an equivalent vector. This equivalent vector, x, is going to have the same magnitude and the same direction. The way we denote our new vector is by finding the change of the y's and the change of the x's. You might have seen this during slope, the delta standing for change. Let's go ahead and do this. And so I ask you to find me an x value. You can give me 4 or 2. So you know what? Since I wrote 2 down first, let's go ahead and write 2. And we're going to subtract this y value, 4. I'll then take this y value, since it corresponds with the 2, and we chose the 2 first, and I'll subtract the 6. This, once we do the math behind it, will be our new equivalent vector, vector x. Well, let's see what this vector is. It's 2 minus 4, which gives us negative 2. And this gives us 3 minus 6, which is negative 3. This vector starts at the origin and whose terminal point goes to negative 2, negative 3. So we'll go negative 2, negative 3. And we will connect this. Excuse me. We will connect this with a vector. So we have a vector going this way like this. Okay? I want you to look at these two vectors here. Okay? They have the exact same magnitude, but they have opposite directions. Well, the good thing is equivalent vectors do not have to have the same direction. They do, however, have to have the same magnitude. So what I want to do is I want to move this so I can show you that they do have the same direction. Well, slightly off, but they do have the same direction. And they have a very much the same magnitude. You might even say they're parallel vectors. And parallel vectors, if they have the same magnitude, are equivalent vectors. You're going to do a little work with this. I may give you the terminal point or the initial point, and you have to find an equivalent vector. Or I might give you an equivalent vector and one of these two, terminal or initial points, and you'll have to find the missing information. I want you to go ahead and try some of these on your own.